Example 2. Interpret the graph of a proportional relationship. The graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. A. What does each of these points represent in this situation? 0, 0, 1, 55, and 5, 275. Each of these ordered pairs represents an x value and a y value. Remember, your x value comes first. Okay, that's your time on your graph. Your time is your x number, and your y number is your distance. So in all of these cases, the y number, or that ratio of y to x, means that we are comparing the distance in miles to the time in hours. So the point 0, 0 means Mr. Brown drives 0 miles in 0 hours. The point 155 indicates that Mr. Brown drives 55 miles in 1 hour. And the point 5, 275 means that Mr. Brown drives 275 miles in 5 hours. Part B. What is the constant of proportionality? Well, in this case, we need to find the y-coordinate when x is 1. So when the x number is 1, what is the y number? In this case, the y number is 55. Here's the ordered pair that tells us that. So the constant of proportionality in this case is 55. In other words, k means he drives 55 miles in 1 hour. That's the unit rate. Then part C says, what equation relates the distance y and the time x? So remember, our equation was y equals k times x, and all we're doing is replacing the k with that constant of proportionality number, which is 55. So the equation is y equals 55 times x. Now let's take a look at the try it question. Suppose the graph of Mr. Brown's road trip is extended. Find the ordered pair with an x-coordinate of 7. What does this point represent in the situation? Well, the x-coordinate of 7 means that the time in hours would be 7 hours. So the way that we can solve that is using the equation y equals 55x. Instead of x, we're going to replace that with the 7 hours because x is the number of hours. That's our time in hours. Now when I do y equals 55 times x, I'm just going to multiply 55 times 7. And the answer is 385. So the graph, if it's extended, will pass through the ordered pair 7 for x and 385 for y. But what it means in this situation is that Mr. Brown drives 385 miles in 7 hours. Now let's take a look at example 3. In example 3, we are just looking to recognize the graphs of what a proportional relationship looks like. And we can examine graphs by going back to example 1 and the conditions that have to be met in order for it to be a proportional relationship. Explain why each graph does or does not show a proportional relationship. So let's take a look here. In the first graph, you see that they have identified this as a proportional relationship. Now, how did they know that? If you look at the graph, it meets the two requirements that we found back on example 1. The graph is a straight line, and it passes through the origin. Remember, the origin is this 0, 0 point here in the corner, where the x and the y-axis meet, and it is a straight line. No curves, no bends. It goes straight from 0, 0 all the way through to the right of that graph. Now take a look at the second example. The second example, they say, is not proportional. I do see a straight line, but in this case, it is only the straight line piece that meets the requirement. What it doesn't do is the graph does not pass through the origin. Remember, that origin is down here, but the graph begins up here. So it's not passing through the origin, which means this is not a proportional relationship. Next, look at the third graph. This also is labeled as not proportional. Why is this one not proportional? Well, in this case, it does pass through the origin. Okay, you can see that right here. The graph starts at 0, 0, but it is not a straight line. So both of those conditions have to be met, or it is not a proportional relationship. The last try it asks us to draw two graphs that pass through the point 2, 3. So the first thing that we need to do is we need to place that ordered pair on each graph. So 2, 3 means the x-coordinate is 2 and the y-coordinate is 3. So we're going to go over 2 and we're going to go up 3. And the same thing on the second graph. Now, when we draw this to represent a proportional relationship, then we have to make sure it meets the two conditions. In other words, we have to make sure that there is a straight line and that it passes through the origin. So we're going to call this first graph proportional. And this is proportional because it is going to be a straight line, and we do have a second ordered pair, that 0, 0, that goes through it. Now in the second graph, we're going to make this one so it is not proportional. And the reason this one's not going to be proportional is because we're going to make it so that it does not start at the origin. So let's pretend that it starts at the ordered pair 0, 1. Even if it's still a straight line, since it goes through a point other than the origin, that's where it starts, it is not a proportional relationship. Now we could also draw a third graph. In this case, I'm just going to draw a quick little sketch. I'm going to draw like an L shape for an X and a Y axis. And we're also going to make this one not proportional. And the reason this one's not going to be proportional is because we're going to put that same point over 2 and up 3 on the graph. But this one we're going to start at the origin, so I'm going to put that origin point there. But we're going to make it so that it is not a straight line. So in other words, it could be a curve or it could be a broken line, such as this one. So it's got two straight parts to it, but it is not a solid straight line that follows one path. So this also would not be a proportional relationship simply because it is not a single straight line. Okay, it is a broken straight line. So not proportional unless it goes through the origin and is a solid straight line. Before we move on to any of the questions to try on our own, I want you to go back to the key concept. And let's take a look at those conditions one last time. Remember that in order for it to be a proportional relationship, that means that we have to have a graph that is a straight line and it has to go through the origin, and that origin point is the point 0, 0. We also can find that constant of proportionality by using a point x and y on the graph and see what that unit rate is equal to. So take your y over x and find that unit rate. Then we can use the unit rate, put it into the equation, and solve to find another piece of information that may not be on the graph. Also, don't forget that the constant of proportionality is the point, in this case, on the graph at 1, 5. In other words, that k number is going to be equal to the point 1, comma, y. So wherever that point is on the graph where x is 1, that's your constant of proportionality point on your graph. Use the key concept information to answer questions 1 and 2. Then come back and check your answers when you're finished. Take a look at the answers for questions 1 and 2. What does the graph of a proportional relationship look like? This was your essential question. Well, the graph of a proportional relationship is a straight line that goes through the origin, or point 0, 0. If those two conditions are met, then that graph is a proportional relationship. Number 2, why will the graph of every proportional relationship include the point 0, 0? And the answer is all proportional relationships pass through that origin, because what that means is that when one number is 0, the other number also has to be 0. Now let's take a look at questions 4 through 7. Martin and Isabel go bowling. Each game costs $10, and they split that cost. Martin has his own bowling shoes, but Isabel pays $3 to rent shoes. So the first thing that I want to do is I want to take this information and I want to make some statements about that. If each game costs $10 and they split that cost, how much does Martin pay per game? How much does Isabel pay per game? Well, if they're sharing the cost of $10 equally, then that means that they each pay $5 per game. Okay, so then we have to consider the bowling shoes. Anytime you go bowling, you either have to rent the shoes that the bowling alley provides, or you can bring your own. It looks like Martin has his own bowling shoes, so he's not going to have to pay any extra. But Isabel pays $3 to rent her shoes. In other words, Martin's bowling cost begins at 0, 0. Why? Because if he has not played any games of bowling yet, his cost is $0. But before Isabel even gets to go bowling for, like on the alley, she's already had to pay money up front. How much did she have to pay? And what did she pay for? Well, remember she had to rent shoes. So before she's even bowled any games at 0, she's already had to pay a fee, or $3, to get her bowling shoes. So Isabel's costs do not begin at 0, 0. Now, each of them pays $5 per game. So after Martin has played one game, his total cost is $5. Remember, he didn't have to pay for his shoes. He already had them. If Martin bowls 2 games, then his costs are $10. If he bowls 3 games, his costs are $15. If he bowls 4 games, his costs are $20. So each time we're just adding the $5 that the games cost. So when you connect the points on Martin's graph, does it meet the requirements of a proportional relationship? Is it a straight line? And does it go through 0, 0? Isabel's bowling costs, however, are a little bit different. She is still paying the $5 fee per game, but remember she had to pay $3 up front for the cost of her shoes. So after she's bowled one game, she's actually paid a total of $8. After she bowled 2 games, she pays another $5, so now she's at $13. After 3 games, she's paid $5 per game, which is $15, plus she paid $3 for her shoes, so she's paid $18. After 4 games, she's paid a total of $23, and after 5 games, she's paid a total of $28. Now, do Isabel's points line up? Is hers going to be a straight line? And the answer is yes. But Isabel's graph does not go through the origin because she had to pay extra for those shoes. So which of these is a proportional relationship? Martin. Okay, Martin's graph starts at 0, 0. And it's a straight line. Number 6 says to choose one point on the graph of the proportional relationship. In this case, we're looking at Martin. And explain what this point means in terms of the situation. So which point do you want to use that's on Martin's graph? Doesn't matter to me. You can pick any point you want. What if we picked the ordered pair 3, 15? That's on the graph because it indicates that Martin played 3 games and paid a total cost of $15. So remember, the way that you can determine that and what it means is to look at what your X number stands for and what your Y number stands for. In this case, remember, X is the games played and Y is the 15 or the cost that he pays for those 3 games. Now the question says, what equation can represent the proportional relationship? So remember, what we're looking for here is the unit rate to replace with the K. In other words, for the proportional relationship, which is Martin's games again, we're looking for what is that unit rate value. In other words, how much does he pay for 1 game? Well, the ordered pair 1, 5 tells us that information. So our ordered pair 1, 5 would show us our Y number over our X number, or 5 over 1. And what that means is our K value is 5. So the equation is Y equals K, in this case we're going to put the 5, times X. Because the unit rate is $5 per game. Now I'd like for you to pause the video while you attempt to answer questions 8 through 11 on page 119. When you're done, restart the video to check your work and answers, and raise your hand if you have questions. And last, let's go on to page 120. And lastly, let's take a look at questions 14 and 15. I'd like for you to try these on your own first, and then check your answers after you're finished, and come see me if you have questions. Please come get help if there's anything that you're still struggling to understand. Otherwise, you're ready to go on and do some independent practice.